So, okay, so now we'll go with the question number 7, which is a Roman number 7, y equal to root of 1 minus cos x divided by 1 plus cos x. Now, this particular question can be done in many methods. So, either here you can go with the rationalization, one method, either you go with differentiating directly, take this one as x, then differentiation of root x is 1 by 2 root x. Or other method is, change this root to half and then use power rule. That is also is one method. Again, one method is also is there, that is by taking log on both sides. Then it becomes an implicit function that you will learn later. Once you get thorough with the differentiation, because this particular question can be done in 6 to 7 methods. So if you are thorough with differentiation, then you will know which method is the best method to solve this question. So now this case, let me go with using identities. Using identities is here, it is easier, okay? Even rationalization also will work. So let me show how to go with the identities. See, as per the identities, for double angle formula, we have sin square x is equivalent to 1 minus cos 2x divided by 2. Now if you see here, we have only 1 minus cos x. So what I can do here is, bring this 2 here, then make it this x. In order to make this x, divide here by 2. If I divide here by 2, you have to divide here also by 2. Then this 2 and 2 will get cancel. So now what will be 1 minus cos x? Now 1 minus cos x will be 1 minus cos x will be, bring this 2 here, 2 sin square x by 2. This is the way to manipulate the identities. Similarly, if you remember, we have one more identity where cos square x is 1 plus cos 2x divided by 2. But here we have only 1 plus cos x. So what I can do? Divide here by 2. If I divide here by 2, make sure you also divide here by 2. And then, logic is same, bring this 2 here. This 2 and 2 will get cancelled. So we will get 1 plus cos x. So what is 1 plus cos x? 1 plus cos x is 2 cos square x by 2 is equal to 1 plus cos x. So, when you get perfect with trigonometric functions, every time no need to show this manipulation. As soon as you see 1 plus cos x, so you have to do mind calculation. Okay, cos square x is 1 plus cos 2x by 2. So if I divide here by 2, there will be divided here by 2, 2 to 1 plus cos x will be 2 sin square x by 2. That way, you need to have this kind of skills. You need to develop these skills. Then only the trigonometric will be much easier, whether it's a differentiation, integration or differential equation. So, this question, I can write this one as what is 1 minus cos x? 1 minus cos x is 2 sin square x by 2, and then 1 plus cos x is 2 cos square x by 2. So definitely 2 will get cancelled, which is equivalent to root of sin square by cos square is tan square x by 2. Square and root will get cancelled, which is equal to sin square x by 2 cos square tan square x by 2. See here, what is sin x? What is tan x? Tan x is nothing but sin x by cos x. Is it okay? So what is sin square x by cos square x? This becomes tan square x. What is sin square x by 2 cos square x by 2? Definitely this is also is tan square x by 2. So that is how sin square x by 2 cos square x by 2 becomes tan square x by 2. Square and root will get cancelled. Finally we have y. Y is nothing but tan x by 2. So how many functions we have? We have 2 functions. One is tan and one it is angle. Differentiate this one. We have divided by dx is equal to, what's the differentiation of tan x? 6 square x. So that means this becomes 6 square x by 2. This angle 1 by 2 is a constant, and differentiation of x becomes 1. Isn't it? 1 by x by 2 means 1 by x by 2 means meaning the same as 1 by 2 times x. Isn't it? 1 by 2 is a constant, so difference of x is 1. Can we multiply this 2 and this 2? Can we multiply? Yes or no? You cannot multiply, because this is an angle which is already controlled by sec. So what you have to do is, you bring this one here. 1 by 2 sig square x by 2. This will be the final answer. Now, one important thing under trigonometric differentiation or whatever under calculus, the answer I got is half sig square x by 2 for this particular question. So now if I go with different method, you might encounter with different answer. Okay? It purely depends on the method you choose. This doesn't mean that every time the answer should be same. So one student might follow this method, another student might go with the rationalization, another student might differentiate directly, or another student will take log on both sides. Doesn't mean that answer should be same. You will come to a different solution, no problem. But if you want to simplify and make it same, you can do it. But it's a long process. I hope you understood this one. That's it for number 7. Okay, so now we'll go Roman number 8. This case, a previous question, number 7, and this looks similar. But number 7, we can use the identity. But here you cannot use the identity. You cannot go with that method. If you want to use identity, you can. By changing this sin x to cos. How do we change sin to cos? Cos 90 minus x is equivalent to sin x. That's a long process, so I will teach you later. I will do that question. But here in this case, let me show you how to go about with the rationalization. Here rationalization looks better. Go with rationalization. 1 plus sin x, 1 minus sin x, okay, times this becomes 1 plus sin x divided by 1 plus sin x. So I am going with the rationalizations here. This way it will be easier. That is equivalent to, I can write this one also. 1 plus sin x, 1 plus sin x becomes 1 plus sin x whole square divided by, this is in the form of a minus b, a plus b. What's a minus b, a plus b, a square minus b square, which is 1 minus sin square. Again can be written as 1 plus sin x whole square divided by, what's 1 minus sin square x? We know double angle of this one. Yeah. As per the Pythagoras theorem, we have sin square x plus cos square x is equivalent to, using this Pythagoras theorem only. You can use this identity, which implies we have cos square x is nothing but 1 minus sin square x. Did you get this one? So what is 1 minus sin square x? Cos square x. Let me rewrite this. This can be written as 1 plus sin x divided by cos x whole square. Right? This is square, this also is square. Square and root will get cancelled. So we have now y is equivalent to, let me give this cos to both of them. 1 by cos x plus sin x by cos x. Here cos x is common denominator. I can give it to both of them. So what is the reciprocal of 1 by cos x? What's the reciprocal of 1 by cos x? What's the reciprocal? 1 by cos x is nothing but sec x. You must have learned in class 10 also this kind of identities, okay? What is sin by cos? It's nothing but tan x. This becomes 1. Now differentiate. We have dy by dx is equal to, what's the difference of sec x? Sec x, tan x. What's the differentiation of tan x? Sec square x. Don't keep here. You can take common outside. That is, I can take sec x common outside, so it will be sec x plus tan x. This becomes the final answer. Okay. Now see this question. Y is equal to root of 1 plus tan x divided by 1 minus tan x. If you want, you can differentiate directly by taking this one as x, then differentiate root x, then inside you do u by v method. You can do that way. Or you change this one to half and then use power rule. That also you will work. But since we are dealing with the trigonometric, never try to differentiate directly. Always try to use the identities as far as possible. This case, going with rationalization, it is not possible here. If I go with rationalization, I will get 1 plus tan x divided by 1 plus tan x, 1 minus tan x, 1 plus tan x is 1 minus tan square x. But what's the identity for 1 minus tan square x? We don't have identity for 1 minus tan square x. We have identity for 1 plus tan square x. See, sec square x minus tan square x is equivalent to 1, which implies sec square x is 1 plus tan square x, not 1 minus tan square x. So therefore, here there is no use of going with the rationalization. But If you want to use identity, you can. By changing tan x to sin by cos. This is also sin by cos. To LCM, you will get cos x minus sin x. Here you will get cos x plus sin x. Cos x will get cancelled, which is a common denominator. Then after that you go with the rationalization. After going with rationalization, you will get cos x minus sin x. Here it is cos x plus sin x, which means this becomes cos square x minus sin square x. What is the cos square x minus sin square x? You will get cos 2x. In numerator, you will get cos x plus sin x whole square, which is cos square x plus sin square x plus 2 sin x cos x. Cos square x plus sin square x becomes 1. 1 plus sin 2x divided by cos 2x. Then you do continuity, but gets complicated. Let me show you one very simple method. That is, if you remember this formula, tan A plus B. You remember this one? What's the tan A plus B? Tan A plus tan B divided by 1 minus tan A, tan B. I hope you remember this. It will be much easier going with this one. See, we have different method as I told you, okay? Choose the best method. Here in this case, let me write this one as a, in place of 1, I am going to write tan pi by 4. Tan pi by 4 is a tan 45. What's the tan 45 value? 1, isn't it? So tan pi by 4 plus tan x divided by 1 minus. You know we have here 1, but we never write that 1. 1 into tan x is equivalent to tan x. In place of this 1, I can write this one as a tan pi by 4 tan x. Now if you see this is in the form of tan A plus tan B divided by 1 minus tan A tan B. Tan A plus tan B divided by 1 minus tan A tan B, isn't it? You can write in that form, which will be root of tan A plus B. Tan A plus tan B. Now it will be much easier by differentiating this function. We have dy by dx. First differentiate root 1 by 2 root of tan pi by 4 plus x. Then differentiate tan, which is sec square pi by 4 plus x. Right? Tan pi by 4 is a constant. Differentiation constant is 0. Differentiate x is 1. So answer we have. Can we do something? No. Go ahead. We keep it as it is. So final answer is sec square pi by 4 plus x divided by 2 root of tan pi by 4 plus x. That's it. Make sure you get thorough with all the identities. Okay.